All right, everyone, thanks for coming to this talk. This is pipeline-oriented programming. And actually, I've decided that's actually too boring. There's so much more other interesting, trendy, techie stuff. So I'm actually going to do a completely different talk on quantum-powered ChatGPT in the cloud. That's much more cool. It's much more trendy. So no, actually, if you know me, I'm never going to let you down. I'm never going to talk about trendy stuff. I'm going to talk about boring stuff like software design and functional programming and stuff like that. So yes, I am going to be talking about pipeline-oriented programming. So I'm Scott Wlaschin. That's me on Twitter and also on Fostodon. The slides and the code, if you want to play with the code, I have a Git repo, and that's linked at my website, fsharp4funandprofit/pipeline. I'm going to do code examples in C# and F#, and I'll start off in C#, and as I get more complicated, I'm going to move to F#, and you'll see why. And this is not really an F# lesson. You don't need to know anything about F#, and actually, if you're kind of curious about F#, this is a good way to see some code. I'm actually going to do some real F# code. You can see what it looks like in action. So, part one, what is pipeline-oriented programming? Well, let me compare it with object-oriented programming to show you the difference. So object-oriented programming, you have this kind of component, and you send a request, and you get a response. So it's a message-based model. And inside this component, an object will talk to another object, which will talk to another object, and there's lots of back and forth chatter between these objects. And sometimes the chatter goes both directions, like something like the visitor pattern, where you're going back and forth. So the thing about this is, in OO, arrows go in all directions. This is the main thing that I want to take away about OO. Really, it's going to get from, people say, well, don't try and do that, but it's very easy to do that in OO. So in pipeline-oriented programming, it's a pipeline, right? All the arrows go in the same direction. And it's an input-output model. So rather than thinking of a request-response, there's a pipeline, something comes in, and it goes through the pipeline, and it comes out the other side. And as it goes through the pipeline, it gets transformed in various ways. Like each of these little individual subcomponents will transform the data, right? So if you know Unix-style pipes, it's exactly the same, right? You have a command line, and you pipe the data through with first command, second command, so on. So it's just like Unix-style thing, except you can actually apply it to all sorts of stuff and not just like command line stuff. So for example, you can apply it to a web backend. So if you think about it, a web backend is an input and output. That something comes in, which is the request, and something comes out, which is the response. And you can actually design a web app using these pipelines without any kind of OO style at all. There is obviously branching, because you make decisions, obviously, but the arrows all go in the same direction. And I'm actually going to show you a demo later on of exactly how to do this. And this is a very different way of thinking about design than you would be if you're doing kind of an OO-style design. So hopefully that'll be interesting to you. So what are the benefits of pipelines? I'm going to talk about benefits, and then I'm going to do some demos to actually kind of push them home. So first benefit, I think, is composability. So composability means like Lego, where you build bigger things and smaller things. I think pipelines actually encourage you to follow good design principles, even more than with OO. I think pipelines are easier to maintain, and I think pipelines make testing easier. And I think pipelines fit really well with modern architectures like onion architecture, hexagonal architecture, clean architecture, et cetera, right? They're different from the classic N-tier architectures. So let's look at each one of these in turn. Let's look at composability first. So composability, I always like to use Lego as an analogy. Lego is a fantastically composable toy, right? So here's some Lego. And the thing about Lego is you can take any two pieces of Lego and connect them together to make another piece of Lego, right? And that's what's so great about it. Every single piece has the little bumps on it, and you connect them together, and the piece that you make still has little bumps on it. So you don't need a special adapter, to add pieces. I could take two of these little toy things and stick them together to make a double-decker, So you can keep adding and adding and making bigger things from a bunch of smaller things. So that's why Lego is such a great thing, and that's why pipelines are such a great thing too, because pipelines encourage you to do the same kind of thing. They encourage you to build pieces that can be connected in all sorts of different ways. They're not like one use only. You could actually design if you're thinking in a pipeline-oriented way, you're just like, how can I build these pieces so they can be connected in different ways like Lego? And again, with pipeline stuff, you design them so they don't need adapters. They can literally normally just be plugged together straight away. And you'll see, well, what does that actually look like? And again, hold on a second, I will show you in a minute. So you get nice composable components if you do this kind of style. And of course, you can glue the small components together to make a bigger component and then encapsulate that. Then you're now hiding what's inside. So you've still got your encapsulation. You now have an input and an output, but you don't actually know what's going on inside. So all the things of encapsulation and stuff, you still get the same benefits of that. Right, number 2, good design principles. So if you're used to OO design patterns and OO principles like solid and so on, these work perfectly with pipeline-oriented style design. You don't have to throw them away. So let me give you some examples. Let's look at single responsibility, for starters. So the whole point of single responsibility is you do one thing and you do it really well, right? You don't have 100 different methods on your interface or your object, right? Well, this has one input and one output. You can't get much more single responsibility than that. So by definition, if you're writing components like this, you automatically have single responsibility. You don't have to check it with code reviews and stuff. You literally can't help it, right? You're forced to do it this way. What about open-closed? So open-closed, you can add new functionality, but you don't mess with existing code. Your existing code works, don't touch it, right? So you can add to that, but you don't want to be messing with existing code. Well, if you do a pipeline-oriented approach, it's very easy. Just add new things into the pipeline. And the rest of the pipeline you haven't touched, right? So you can add it before, you can add it after, you can add it in the middle, all right? So you've extended the behavior, but you haven't touched the rest of the code. So the open-close principle works really well with pipelines. In fact, again, I think it's like it just falls out naturally. You don't even have to try. It just kind of comes with the territory. And I'm going to show you some examples of this in a minute, including one that you're all very familiar with, which is LINQ. So I'm going to start with a LINQ example, and it'll demonstrate this perfectly. Strategy pattern, right? You have some sort of piece of code, and you want to parameterize how it works by passing in some sort of strategy. Well, you just pass in a component, right? This is my whole pipeline. I want the behavior to change based on something else. Well, I just pass in a component. If I pass in a different component, it's going to behave differently. But I'm not messing with the rest of the code. So that's very easy. And decorator pattern, again, I have a component. I want to change the behavior. Let's say I want to log the input and log the output. I can just add new pieces at either end and then encapsulate that. And now I have a new pipeline which has the same inputs and outputs as the original pipeline. So it's completely substitutable. Everywhere I could use the original pipeline, I can now use this decorated pipeline. Right? So that's the decorator pattern. So all these things are kind of so obvious you don't really need to talk about them. They just kind of follow from the whole pipeline-oriented way of doing things. Right. What about easy to maintain? So this is a bit of a claim, because I don't actually have any evidence. But to be honest, there's hardly any kind of rigorous evidence for anything in programming, which is sad. But I'm going to claim that the bottom one, the pipeline one, is easier to maintain than the top one, the object-oriented one. And I think the reason is because with the OO1, you can really get into a mess. You can have these guidelines like, don't do that, don't get into a mess, don't have 100 methods, don't have it. But it's really easy to do it, especially if you're trying to get something out of the door at 3 o'clock in the morning on a Friday or whatever. So, with the pipeline thing, it's really hard to, you're less likely to get into the mess in the first place because it just doesn't really support that way of thinking. And here is an example of a real-world dependency graph for a C# project. You can't see it, and this is actually just a quarter of it. Each of these things is a little class, and the lines are the dependencies between the class, and you can't really see them. But what I can tell you is that the arrows in this go in all directions. And trying to understand how this works is going to be quite confusing, right? And in particular, one thing which is really bad is you have these circular dependencies where a class depends on another class, which depends on a third class, which depends on the first class, and you have some sort of cycle. Those are deadly. They really shouldn't exist. And again, you can have guidelines to say don't do that. But if you do that, then you've broken your laying. You can't refactor these things. You can't pull these things out. So cycles are really, really deadly. And if you're using C#, I would recommend using something like ndepend or something which will help you detect these things, but definitely don't have them. Now, here's the F# version. And this is an F# version of the same logic. So it's a lot fewer. These are not classes. These are modules in F#. But what you can't see really is that all the arrows are going in left to right. So if I'm trying to understand this code, obviously it's quite complex, but again, there's no cycles in this code. It's all one way. So that's nice. Right, so 2 more benefits I talked about, which was testing and architecture. I will leave that to the end, because I don't want to bore you with too much talking. But at the end of the talk, I'll go back to testing and architecture and see, hopefully you'll see that it works really well for this. Right, so let's actually look at some pipeline-oriented code in practice. Enough talk here. So this is a for loop in C#, and it's a very stupid example, but trying to figure out what it does is not 100% easy, because there's various things, there's a branch, and there's various things going on, there's a mutation, and so on. Right, let's look at the same code in LINQ. Right? Now, I claim that this is easier to understand than the for loop. Right? I mean, I can just look at this, and I can see what's going on. Now, it's not necessarily as performant. The for loop might be more performant, but in terms of just understanding what the code's doing, I think this is easier. Because I can see that you're converting, you're adding 2 to everything, and then you're doing a filter, and then you're adding the count, you're returning the count. I think this is much easier than the for loop thing. So LINQ is a great example of pipeline-oriented programming. So if you've ever done LINQ, you already know how to do this. Now let's look at the composability. So in LINQ, all the different methods do one thing. They do a single responsibility. They do one thing, and they do one thing well, and they're designed to fit together in different ways. Right? It's a composable. LINQ is a kind of Lego-like system. You can mix and match all the different components, right? So that's nice. And so what I'm trying to say is LINQ is a great example of how you should be writing your code. If you can write code in a way where you can mix and match your components and then connect them into a pipeline, that will be it's a really nice design. There's the single responsibility. Each one of these things does one thing, and because of that, it's easy to understand what it does. Once you understand what this particular method does, it doesn't do 20 different things, it does one thing, and it does it well. And if you're writing this kind of stuff, it's easy to test, because I just have to test the thing in isolation, and then when I put all these different pieces together, each individual piece has been tested, and I can be pretty confident that the whole thing's going to work. Right? I don't have to worry that the whole thing's not going to work, even though the individual pieces work. Like, if the pieces work, I still want to do some integration testing, sure, but I'm not going to worry that it's broken. I'm going to be pretty confident that it's going to work. And then, of course, you can add and remove things from the pipeline. I can add another where clause. I can add another select clause. I can do a sort. I can do, all the different things you can do with LINQ, right? There's like, 50 different things you can do. So I can easily add things to the pipeline, and I'm pretty confident that I haven't broken anything. Now, if I was going back to the for loop and I wanted to add another filter, would I be confident I haven't broken anything? I don't know. I'd have to be really careful when I change that for loop, because I might break something. But here, I'm very confident if I add a new thing, I haven't broken anything. So here's the F# code, the same kind of thing. So F#, you can use LINQ in F#, but F# has its own built-in collection, stuff like this. So select is called map in F#, and where is called filter, and in the count it's called length. And this is exactly the same kind of code in F#. Now, the thing about F#, it uses this pipe operator. And in Unix, it's a vertical bar, and in F# it's a vertical bar with an angle bracket. So the vertical bar is used for something else, right? So it's vertical bar, angle bracket, and you will see this all the time in F#. So this means take the list, the list collection, feed it into the map function, and add 2 to it, and then take the output of that, feed it into the filter function, take the output of that, and feed it into the length function. So it's very similar to LINQ. These are not extension methods. These are standalone functions, so it's slightly different. Right, now, one thing where pipelines are really useful is when you're doing immutability, right? So more and more people are using immutability, which I think is great. I think everything should actually be immutable. If you are doing immutability, you're probably going to need some sort of pipeline thing. And I'll give you an example. Let's say I have a record structure here. And this is immutable, so I want to modify the name, and then I want to modify the email, I want to modify the age, and so on. Each time I do that, I'm creating a new version of the person. And it's quite common to do this kind of thing, and this is really ugly, right? It's very repetitive, it's kind of ugly, Let's not do it. Let's not do it. This is a kind of, I would say, ugly code. So what's the alternative? Well, you can just dot them, do a cascade of dots, right? So a kind of fluent interface would be another way of talking about it. So fluent interface is another way of doing pipeline. Same kind of thing. This is much nicer. You don't have to have all these variables and stuff. So pipeline-oriented stuff makes immutability. It's very, very common where you have a chain of functions or methods and you're modifying something as you go through. And obviously this is, oh, dear. I just got a blue screen. Sorry about that. I'm just going to restart my computer. That is kind of annoying. Sorry, folks. Of course, that's Murphy's Law that would do a blue screen right in the middle of a presentation. I wonder what's something there. Okay, well, I'll have to just talk among yourselves. Anyway, so what was I going to say? Oh, yeah, immutable data. So how many people, I'm just curious, how many people are using mutable stuff in their code now? A lot of people, yeah. So presumably you've run into this problem where you have to kind of chain data. Actually, another good example is LINQ, where the sequences are kind of immutable. You're making new sequences as you go through the pipeline here. Well, just rebooted. Let's see if I can. Where am I? Right, here we go. Okay. So, yes, this is ugly, and this is much nicer. And another thing you might be thinking about is something like LINQ is an extension method, right? What's the difference between extension methods and piping? Like in F# you use piping, and in LINQ you use extension methods. So I'm going to demonstrate that too. Let's say you have two functions, right? 3 functions actually, and I want to add one, and then I want to square it, and then I want to double it, right? So the traditional way would be to use some sort of nested call like this. I find that kind of, sometimes you get really deeply nested and it's kind of ugly, right? So if I want to make this look nicer, I'll use a pipeline, right? I'm going to use a pipeline. So 5, and then add 1, and then square, and then double. That's much easier to see what's going on without all this nesting stuff. Problem is, of course, this doesn't work because these things are not extension methods, right? So I can't do that. However, there is a trick that I can make these work. And the trick is I can make a generic helper that will turn anything into an extension method. And that is going to be called pipe, right? So this is the pipe in C#. It's got a lot of generic parameters. It's got 2 generic parameters. So it's a bit confusing. It's kind of hard to look at sometimes. But basically, there's an input here, and that's the input. And then the other thing you pass in is a function, which has an input and output. So it's a 1-parameter function. And all you do is just call the function with the input. That's it. So that's what pipe is. It's pretty easy to go with, except for all the generic stuff. Now, if I use this pipe extension method, I can actually go back and rewrite this using piping. So, I think that's nicer. Now, obviously, this is in real life, you would never do this for adding and squaring numbers. Obviously, it's way too simple. But you can get the idea that you can actually, if you had a more complex thing, you could actually turn it into a pipeline quite nicely. Now, the problem is this only works for functions with the 1 input. So how do I do 2 input functions? Well, I just have let's say, adding 2 numbers together or multiplying 2 numbers together. They won't fit into the pipeline, right? So how do I do that? Well, I just have another overload of pipe, and I have an extra parameter now. And when I call the function, I pass in the original input, which is coming down the pipeline, and also the extra parameter, the second parameter. Right? So that's how you would implement a 2-parameter version. You can have a 3-parameter version and 4. You can have overloads, as many overloads as you like for this. So if I do that overload as well, then I can use addition and multiplication in my pipeline by just passing in the extra parameter, right? So there's my extra parameter, and there's me passing in the extra. So the 5 is passed down the pipeline as the first parameter, and the 1 is added as the second parameter. So that's going to be 5 add 1, right? And then it's going to be, which is going to be, what, 6? And then the second one is going to be 6 multiplied by 2. So why, again, in real life, you wouldn't do this for simple multiplication. But why would you even bother to go to all this trouble of having a special pipeline? Well, again, because we can do all this stuff like adding things into the pipeline, removing things in the pipeline, composing different functions together in different ways. Right? So all the benefits that I talked about with the LINQ, so this is not LINQ, this is adding and multiplying numbers together. But now I have a composable version of that. If you wanted to have a kind of building blocks for doing mathematics, I could do it this way. Same kind of thing. One really nice thing about this also is the diffs look great. So if you're doing a code review and you're seeing what code changed, when you're doing pipeline-oriented stuff like this, the diffs are really clean. It's really, I've added something in the middle of it, or removed something, but you always see these really, really nice diffs, which is not going to be true. If I'd gone back to my original for loop and I've modified things, it would get really, it's not obvious really what's going on. So just in terms of communicating what's going on, pipelines are great. So here's the F# code for adding and multiplying and squaring and so on. Again, I start with 5, I feed it into add 1, I feed it into multiply 2, and so on and so forth. So F# we'll see uses pipelines everywhere. So these are not extension methods. Notice I didn't have to write a special pipe helper. In F# you get it for free, because in F# functions are sort of pipeline compatible out of the box. Almost all functions are pipeline compatible. So sometimes in C#, and I'm going to start using F# more and more, because in C# it can get a little bit kind of frustrating, like using pipe. I mean, you can see it's not really a natural fit for C#. I mean, it works sometimes, but in F#, it's never going to make you cry about, not having the right adapter and so on. So, the thing about extension methods compared to pipelines is you can't use them as parameters. So let's say I have a strategy like this. I have a list and some sort of strategy function, and I'm doing that same kind of LINQ thing where I'm selecting something, and then I'm doing a where clause, and I'm doing my count. And in the middle, I want to inject my parameterized function. Maybe I'm going to do a different filter, or maybe I'm going to do another select or something. I'm going to decide, oh, blimey, it's gone again. Sorry, people. I've got another blue screen. Why is it doing that? I'll try and keep talking while I reboot again. Of course, I don't know, maybe it just doesn't like this room. Hopefully there's not too much downtime between the reboots. Sorry about this. Okay, so what was I saying about the injecting a parameter? It's hard to do that because these, the functions that the methods you inject can't be fitted straight into the pipeline. So what you can do, and if this does this again, I'm going to go crazy here. I wonder if it's overheating. So I was saying that if you can't pass in a strategy function and use it directly in the pipeline, but you can, that's not going to work, right? You can't just use a function parameter. But what you can do is use the pipe helper function to do this. Now in F#, here's the same F# code. With F#, as I say, all functions are kind of automatically pipeline compatible, so I don't need the special helper to do this. So you can see, as I get more and more into pipeline coding, I'm going to be using more and more F# because it just gets kind of unwieldy with C#. So you can do it with C#, with extension methods and with helper functions like pipe, but F sharp is like, so as I get into more stuff, it's going to be more F sharp. Right, so I'm going to do 3 demos to actually show you some real code. I'm going to do pipeline-oriented Roman numerals, pipeline-oriented FizzBuzz, and a pipeline-oriented web API, as I promised. Now, all these are pipeline-oriented, and one of the things when you do pipeline-oriented programming is you start designing the solution differently than if you were doing OO. So each of these is going to have a very different design that you might think of normally, right? So let's start with Roman numerals. So this is something you've probably all played with a bit, right? You convert 5 into V and 12 into X11 and so on and so forth, right? So there's lots of different ways of doing this, but I'm going to do a pipeline-oriented way. And I'm going to base this on the fact that I think the Roman numerals were originally sort of a tally system where you kind of make a whole bunch of marks on the wall and then you cross them out when you get to 5 and cross them out when you get to 10, something like that. So that's going to be my design. I'm going to start with n copies of the letter I, so like 42 copies of I. And then every time I see 5 I's, I'm going to replace it with a V. And every time I see 4 V's, 2 V's, I'm going to replace it with an X. And 5 X's is going to be an L, and so on and so forth. So literally going to do search and replace. That's my algorithm. So in a pipeline model, this is what it looks like. I start by making 42 copies of the I, and then I just go through each replacement step in turn in the pipeline. So that's my algorithm. This is an algorithm you probably wouldn't come up with if you weren't thinking about pipelines. You probably have some sort of for loop, right? So here's the C# code. Right? I make a string with n copies of it, and I do a replace, and a replace, and a replace, and a replace. Right? Now, you might notice that I haven't done the extra cases like 1V. There's some special cases, like 4 is actually 1V, not 4 ones. Well, we can just add some functionality to our pipeline. Really easy, right? I can extend the behavior of the pipeline without touching the original code. So this is a good example of how I can, like, oh, we've got a new feature request. We've got to add these new special cases. Oh, yeah, just add them at the bottom of the pipeline. And again, your diff is going to look really nice when you do this. It's like, what have you changed? I changed these 4 lines. Here's the F# version. Very, very similar, except I'm using the pipeline. Instead of using a fluent interface, like with the C#, I'm using the pipeline-oriented version with the vertical bar. Let's see if I can do a demo without crashing my computer here. Whoops. And now, of course, I have to restart Visual Studio. Super duper speedy Visual Studio. Right, so here's the C# code, as I promised. And let's say I want to do some logging. Right, so in the C#, I can add new features into the middle of the pipeline. I can do a log. I can do a log afterwards. I can do a log at the bottom. So in C#, I'm going to have to do this by having an extension method for strings to do the logging, to keep it fluent. If I do the F# code, I don't have to do that. So let me show you the F# code. Now, the nice thing about F# is you can actually run it interactively. So I can highlight this code and then actually get the answer. So there's the answer, XXX. So notice I haven't done the special cases. So here's the version with the special cases. I've just added some extra code at the bottom. And now, if I do it, I get the nice one with the 1x and the XL and so on. And then here's my logging function. So this is a standalone logging function. It's not an extension method. So I could actually reuse this in many different situations. Because all functions are kind of pipeline compatible, I can just stick it right into my pipeline. So there, I'm logging in the middle. I'm logging at the thing. And let me just put this here. There we go. Oops. So that's what it says at the start, and then before the special cases and the end. So the logging is working very nicely with the pipeline. Right. Now let's talk about FizzBuzz. So if you're not familiar with FizzBuzz, you're going to write a program that prints numbers from 1 to n, but if it's divisible by 3, you print fizz instead of 3, and for 5, it's buzz, and for 15, it's FizzBuzz, and so on. Hopefully, you will know how this works, right? So here's the C# example. This is a pretty standard implementation, right? I'm just looping from 1 to 30, and I'm just comparing the different things. So this is great. If you're doing a job interview, definitely do it this way. But we're not going to do it this way, because this is too easy. We're going to make it more complicated, right? So no, I'm not going to make it more complicated, but I am going to make it more composable. So the problem with the classic version is I want to add new features to it. It's just a monolithic piece of code, right? So if I need to add 7 or something, I want to add logging, I'm touching all the code. I'm not doing the open-close thing. If I could make it a composable system, I could add logging, I could add new numbers without touching the existing code. So let's do that. So again, we're thinking pipeline. How can I make a pipeline-oriented version of this? Well, I'm going to handle 15, I'm going to handle 3, I'm going to handle 5, and then I'm going to have the final step where nothing's been handled. Right? So this is a pipeline of data flowing through this pipeline. Now, in order to do this, let's look at each one of these steps. So this number is going to come in, but there's actually 2 different things that could happen. One is that I'm not going to handle that number. Like if for like 3, then 2 and 7 don't count. Right? I'm just going to ignore them. On the other hand, if it's 3 coming in, then I might want to put fizz as the output. So I need to handle both these different possible outputs. So what I'm going to do is create a new data structure specifically for this problem. And the nice thing is you can do it in 1 line of code. Now, normally it's not like a big deal. It's just like 1 line of code just to solve this problem. I think that's a price worth paying to get the composability. So my FizzBuzz data structure down here, is going to have a string, which is the output, and the number that's being passed through. Now, if the string if the output string is empty, that means I haven't processed it. And if the output string is not empty, it means I have processed it. So there are other ways of doing this, but I'm just going to keep it very simple for now. So let's see how we handle something, right? So I pass in the data structure, and it's an extension method because this is C#. The number I'm dividing by and the output that I want to have, fizz or buzz, whatever. So if it's already been processed, if it's not empty, I'm going to do nothing, just return the data. If it's not divisible by the thing, it's not applicable, I'm going to return the thing. Otherwise, I'm going to create a new version of the data structure and I'm going to put the output in it. Right? So now it's been handled. So that's my handler. Right. Now, once I have a handler like this, I can chain them together. Right? So there's the input. And that is the data that's being passed down the pipeline because it's an extension method. Right? That's the first parameter is what's being passed through the pipeline. So I start off with an empty data structure. I handle the 15 case. I handle the 3 case. I handle the 5 case. And then the final step is basically turn it into, if it hasn't been handled, turn it into a string. So this is my FizzBuzz pipeline implementation. Now, this is probably something you would not normally do unless you were thinking about pipelines. And then finally, I can actually do the 1 to 30. I can do that as a pipeline. Well, I'll start with enumerable and then do a select. I'm going to use LINQ. So there's a little mini pipeline in there as well, just for fun. So that's going to print it out. Right, so let me do a demo. And I'm also going to show you how I can do parallelization with the pipeline-oriented program, which is very nice. Right, where is my FizzBuzz? So here's the classic version of FizzBuzz in F#. Same kind of thing as the C# version. But let me show you the F# one. So here's my data structure. Here's my handler. It's the same code as the C# one, right? If it's empty, if it's not empty, I've already processed it, and so on. Here's the final step, which I didn't show you, which basically turns it into a string if it's not been processed. Here's a little logging thing, which I'm going to use later on. Right, so here's my FizzBuzz pipeline. Right, you can see that it's piping each step through the handle 15, handle 3, handle 5, and so on. And again, if I want to actually run it with different numbers, there we go. Let's actually run it and see what happens. There we go. 1, 2, fizz, 4, buzz, 6 is fizz, 15 is FizzBuzz, and so on and so forth. So it's working. Right, now, let me add some logging, and let me add a new handler. So let's start with 7. So you say, well, you need to handle 7 as well. So, OK, I've got a new feature, And I don't need to change any existing code. I can just add it. So I'm very confident this is going to work. If I was doing that for loop thing, I mean, FizzBuzz is not that hard, right? But if it's a more complicated, I wouldn't necessarily be confident it's going to work. But this, I'm very, very confident it's going to work. So let me do this. And where's the answers? There we go. So I got zap in 7, zap in 14. Now, what I haven't got, if it's 7 and 3, I should have fizz zap, but I only got fizz. So I'm not handling the combinations, right? And you say, well, that's a problem, and I'm going to fix that in a minute. So just hold on. And then let me add some logging. I'm just going to put a log right here. Log after 5. And I can say log after 15. Okay? So I've got some logging going on. I can stick it in the pipeline, no problem. And now, if I look at the output, you can see it's logging after 15. So after 15, 30, like 30 is outputting FizzBuzz and so on. So you can actually see I've got logging going on automatically. Right, now let's talk about this thing where I want to do it in parallel so I can handle 7 and more complicated things without having to do special cases all the time. So what I'm going to do is I'm going to do a parallel version. I'm going to pass in a list of handlers. And what I'm going to do is just run each one independently in parallel and then add the results together. So I just need this combine operation here. And there's my handler. By the way, notice I'm doing a map followed by a reduce. So if you know about parallel programming, you know there's a thing called map reduce. And here I am actually using it in real code. So let's do the parallel version. So here I'm getting my FizzBuzz automatically, even though I didn't actually have the FizzBuzz case because it's doing it in parallel. And if I add 7, again, I can just add 7. I don't have to change any other code. And now if I do it in parallel, I'm getting, oops, I should put in zap here. Right, there's zap, but I'm getting, if I go to 21, I'm getting fizz zap, right, 3 and 7. And if I go to 35, I'm getting buzz zap. So it's doing I don't have to have all these special cases anymore because I'm doing it in parallel. So this is something that you would never think of doing, really, unless you were thinking about these components. Like I've got this little handler, and this is a single responsibility thing. And once I've got this handler for 1, I can compose the handlers for different numbers together, run them in parallel, combine the results. It's a whole different way of thinking about how you might write a program. But it all started because I was thinking about composability. Right, now let's finish up with a web API. So what does a component in a web pipeline look like? So I'm going to have a pipeline for my website, and it's going to have components which are composed together. So how do you even do that, right? So here's what a web component is going to be. It's going to have an input and an output, right? Now the input is going to be called HTTP context, which contains the request and the cookies and everything you need to know. It's also going to have the response, because you might have partially written to the response, right? So the response is also going to be part of the input for this thing, and you might add to the response or replace the response and so on. Now there's 2 different cases. One case is you've handled it. You say, oh, this is something that I can deal with, and I'm going to handle it, just like FizzBuzz. And another case is like, no, this is the situation I don't want to handle, so I'm not going to handle it. So again, there's 2 different outputs. So if you think about, if you're used to middleware in .NET, ASP.NET, it's kind of like that, but I actually think this is easier than the middleware thing, because it actually works everywhere. You'll see that it works. I can build an entire site this way. So again, going back to this sort of railway track analogy, which I like to use, it's like having a branch in your railway, right? So either something comes in, and I either handle it and return something. And by the way, it's actually, in practice, it's an async that comes back. So, because you can actually go out and hit the database or something. And then, if it doesn't handle it, it just returns null. So I've got this branching code. So let's look at a very simple web component. This is called get. So all it does is look at the request and see if it's a get verb. And if it is, I've handled it. And if it doesn't match the verb, I don't handle it. That's all it does, one thing, single responsibility. All right, let's look at another one. This one is called route or route. And it looks at the input, and it sees what the route or route is. And if it matches, I'm saying, yeah, I handled it. And if it doesn't match, I didn't handle it. Right? Again, single responsibility. Here's another one, set the status code. So all it does is set the status code to something. Right? Now, this one's always going to work, because it's just going to replace the response. So I have these three different components, and I want to glue them together into a pipeline. How do I do that? Right? So I have a get, followed by a route, followed by a set status code. Well, I'm actually not going to tell you. Well, I'm going to show you how to glue them together. And we're going to use this special kind of pipeline. This is not the normal pipeline. It's angle bracket equal angle bracket. Special kind of pipeline for these kinds of things. So I'm not going to really show you how it works, but if you've ever played with a toy train set, it looks like this after you combine them, right? So if you know how to work with model railways, that's how it works. So that's how it works inside. It's actually pretty easy, but I'm not going to go into it right now. Let's look at another web component. Let's look at choose. So what choose is it takes a list of web components. And each web component can, return, I handled it or I didn't handle it. So what choose does is it goes through each one in turn, and it finds the first one that handles the input. So if, in this case, maybe it's the first one. Now, if none of them handle the input, the whole choose thing doesn't handle it, right? So choose itself is one of these things where there's an input, and if it's successful, it will return an output. And if none of them work, if none of them match, it will return nothing. So it itself is another web component. So you can see I've built a bigger web component from a bunch of smaller web components. So here's an example of a very simple web app. So I've got the get combined with the route, combined with the OK, which is a 200. Right? So if it matches get and it matches the route, then it's going to return OK, hello. And if it matches get, and if it doesn't match, the first one's going to fail. Now, if it matches get and it matches the route, and the route is goodbye, then it's going to turn out goodbye. So if that one succeeds, the whole thing will succeed. If none of these succeed, then the whole choose itself is going to fail. Right? So there's a little, very, very tiny web app written using pipeline approach. Right? So there's a very different way of writing a web app that you might normally write. So, of course, because this is a pipeline, you get all the benefits of pipelines. So I can add a new pipeline, a new thing to my choice. Right? I have a post. If it's a post and the route is bad, it's a bad request, and so on. And I can do things like checking whether you're logged in. If you are logged in, are you in the right role? So all these things, I can just have these single responsibility components that I stick in my pipeline to build my entire web app. So each one of these things is very small. It does one thing well. And they can be tested independently. Plus, I think this is easy to understand. If you're looking at my code and you're saying, what does it do? You can look at this code and say, oh yeah, well you have to be, it's this path, and you have to be authorized, and you have to be an admin. It's a lot easier to understand this code, I think, than trying to understand some complicated other kind of code. So again, just like with LINQ, all the components are composable, they're reusable, they're testable in isolation, they're single responsibility, all the stuff, all the good stuff I was talking about. This is a real-world example of it. So the Lego model applied to website development. Now let me actually prove that it's not just a toy thing. I'm actually going to do a real app here. So this is my program. And by the way, this is actually using, it's sitting on top of .NET. This is actually a very old version of, this is like 4 years old now. So I'm using a framework called Giraffe, which is an F# framework to do this stuff. But you can see it's got a startup function and so on. So once you get out of the .NET stuff, you're into this nice F# stuff. So here's my thing. So get, if it's hello, I'm going to return hello. If it's a post, so I can differentiate between a get and a post. If you post a hello, it's going to return post hello. If you pass in a parameter, like your name, it's going to say hello with name. So this is a little function I wrote myself, and all it does is it takes the name parameter and it just spits out the name instead. Goodbye, all it does is it says goodbye. There's a ping pong handler. Let's look at this one. So it's just another little choose. So this component is a choose, right? So if the input is ping, it's going to return pong, and if the input's pong, it's going to return ping. Right? The next one, JSON. So here's a good example of little JSON. So all I've got is a very little simple data structure, and I'm going to serialize it to JSON and return it. That's about as easy as it gets, right? What else do we have? Oh yeah, here's a proper database. So this is something that loads a customer from the database. And this is my customer database, and let's look at this code. This is actually my database, but you could imagine a real database behind the scenes. But basically, I've got 2 customers, and if it's 1 or 2, I return the customer, and if it's anything, if it's not 1 or 2, the customer's not found, right? So obviously, I could replace this with a real async code, because all this could work totally with async. So that's my customer database. So what I'm going to do is load the customer from the database, and it might exist or it might be an error, right? So if it does exist, it's going to serialize the customer and return it. If the customer doesn't exist, I'm going to return a 400, and I'm also going to take that error message and return it in the response as well. So there's obviously it's a very simple example, but you can see that you can get more complicated stuff going here. How about access denied, right? So if you go to the denied, let's see what that does. So denied, I'm setting the status code to 401, and I'm going to return this text as well. And finally, the home page is just literally going to load up a static page, and show it on the screen. So let's actually run this, see if it works. No, I don't want one time, thank you. Right, so I've got it. My static page just has a bunch of pre-built buttons, so I don't have to type all this stuff in. So I've got hello, right, and that just returns hello. And there's the post. So I've got a post and a get, and you can see that it returns different things. If there's the parameterized version of hello with somebody's name, and just to prove it works, I could put in somebody else's name in here, and it still works fine. What else do we have here? Right, get goodbye. So this is my message. Don't say goodbye, NDC. Never going to say goodbye. I'm going to say hello to NDC. Right, there's ping, which returns pong. And there's pong, which returns ping. And there's my JSON example. Right, so I had a data structure in F#, and I just serialized it to JSON, and there it is. What else do we have? Oh, here's my customers. Right, so there's customer number 1, parameterized by number 1, customer number 2, and if I put in another customer which doesn't exist, customer 42 doesn't exist, that's not found. And by the way, never write your APIs where you're passing in customer IDs. It's just for demo purposes. This is like really bad security. Right, okay, what else do we have? Oh yeah, get denied. So actually, let me open up the network and show you that it really was denied. There we go. You can see over here with a look. There you go. I got a 401 there. Right, so it really did return a 401, and it really did return an access denied message. Right, okay, so this is a working website. Obviously, it's pretty simple, pretty crude, but I did some database access, I did some JSON serialization, I did some security with access denied. You can actually write serious apps. Now, you might think F#, is that the best thing? Well, it's running on .NET. It's just as performant as C#. So if you're happy to write a backend in C#, there's no reason why you can't write a backend in F#. It's just as performant. So, and I can also, of course, I can put logging in there. All these little pipelines, I can do all the stuff I can add to the pipeline. I can move things. I can add logging. I can add, authorization and stuff, because it's a pipeline. So this is F# Giraffe. So highly encourage you to check it out if you want. So all the code I've shown you is actually on my GitHub. And if you go to the F# for Fun and Profits /pipeline, there's a link to my GitHub repo, so you can download it and play with the code yourself. Right, so let's finish up with talking about testing and architecture. So I said at the beginning, I think that pipelines encourage good architecture. So what do I mean by that? Well, if you think about the modern architectures, onion and clean and hexagonal and ports and adapters and all those things, the difference between them and the old-style database-centric ones, like an N-tier, classic N-tier. So in classic N-tier, the database is at the bottom, it's the core of the system. In the modern architectures, the domain is the core of the system, and everything else is on the outside, the infrastructure and any APIs that you're interacting with, the database and so on. All this is on the outside, and your core domain is in the middle. That's the most important thing, right? So how does this fit into the pipeline? Well, you write your pipeline the same way. You have a piece of pipeline which is pure domain logic, just business rules and whatever, decisions. And then anytime you interact with the outside world, you do that at the edges of your pipeline. So this is very easy to work with. I actually think it's easier than trying to do this OO stuff. If you're using Entity Framework or something, it's kind of messy. But if you're using this kind of pipeline stuff, it's kind of natural to put the I/O outside. So the core domain is pure, it's deterministic, it's predictable. Anything which is unpredictable, anything to do with networks and databases and all that stuff is on the outside of your app. So I think it encourages good architecture. So here's a pipeline with the business logic. The decision making is in the middle, right? And like I say, it's really easy to enforce this when I'm looking at the code, if you're doing a code review, because you're not mixing up different things in the same. Each piece is a single responsibility, so it's really obvious whether it's doing wrong things, So classic things, you load some data from the database or you receive some data on the network, you process it, you analyze it, you come to decisions like, should I do this, should I do that? And then based on that, you write some more data out of the database or you return some more data back on the network or whatever. So that's the classic. Obviously, 99% of business applications literally just follow this model. Sometimes you have to make multiple decisions, that's fine. But in that case, I recommend you keep each step separate. So you have a decision-making step and an I/O step, and another decision-making step, another I/O step, and keep them separate. Now, what about testing? Why is this easier to test than conventional code? Well, again, looking at this thing, this bit in the middle doesn't use any I/O. So it's completely deterministic, right? If you have a particular input, you'll always get the same output, right? It's what you call pure code. Right? The stuff on the edges is not deterministic. Every time you load a record from the data, you might get a different answer. So, that's very hard to test. But if you design your code this way, the testing falls out really easily. You do your unit tests on the middle bit, and you do your integration tests on the entire pipeline. So it just falls out. And by the way, a unit test is not a class-based thing. A unit is a unit of functionality, right? You're testing, that's what a unit is. So don't think of unit tests as class-based tests. It's a unit of business logic is what you're testing. So I'm testing the middle bit, and it's very easy because there's no I/O. It's like completely deterministic. This input gives me that output. It's really fast to run, really easy to write. And then you can save the integration tests for the entire pipeline. So to finish up, why bother with all this pipeline stuff? Well, hopefully, I said at the beginning, and hopefully I'm going to go to persuaded you that these things are actually useful. I talked about reusable components, and you can see, especially like with the web app, that each of these little individual things are completely reusable. I can mix and match, build pipelines in complicated ways. I said that I think it's more understandable. And again, if you look at that web app, I actually think that is a lot more understandable than a classic web app, because all the code is like in one, all the kind of overview is in one place, and all the individual components do their stuff. Just like with the LINQ code was more understandable than a complicated for loop, right? So I definitely think pipelines are easy to understand. We talked about extendability. You can see it's really easy to add new components. I can add new components. I can add new features to my pipeline really easily. And I'm not touching any old code. So I have very high confidence when I do add a new piece to my pipeline, I'm not going to break anything. And that, to me, that's worth a lot. Much more testable. Each of these individual pieces are one single responsibility. They can do one thing. They're much easier to test in isolation. And then when I do combine them, I have high confidence that they're going to work as a whole, that there's not going to be some weird side effects and interaction between them that I wasn't expecting. And finally, it's just a different way of thinking. I do think that it's good for your brain to learn different ways of thinking. And if you've only ever done OO, I highly recommend you learn other ways of thinking. I suggest pipeline-oriented functional programming, logic programming like Prolog, stack-based programming like Forth. It's really good for your brain to learn these different ways, because if you learn these different things, you will come up with different solutions. Like pipeline thinking gave me 3 different solutions for things you probably would do normally in a very different way. You'd probably never write the Roman numerals thing that way. You'd probably never write FizzBuzz that way, and you'd probably never write a web app that way. But I think that if you're thinking pipelines, you'll start thinking that way about solving your problems. So, is it going to work in every situation? No, I'm not claiming this is a universal tool that will help you for everything, but I think it's part of your toolkit, right? Every developer should know about databases, they should know about OO programming, they should definitely know about domain-driven design, and I think they should know about pipeline-oriented programming. So it's just a part of your toolkit that you can reach for when you have a particular problem. So that's the talk. Like I said, I'm going to put the slides and the video up on my website. So this is f#for-fun-and-profit/pipeline. And also my code is there if you want to run the code for yourself. If you like this talk, I have other talks. I have one on composition, and I have one on railway-oriented programming, which is where I talk about how you can combine these multiple track railways into a single system. It's all about error handling, functional error handling. So I like that one. And then, of course, I have a book, Domain Modeling Made Functional. And you can find me on Twitter at Wlaschin, and I'm also on Fosterton with the same handle. And yeah, if you have any questions, please contact me there. So thanks very much. And I'll be here for questions. I'll stick around for a bit if you want to come up and ask me questions. So thanks very much.